How do emotions link to other cognitive functions? And of course, I could teach a whole course about this, but for the sake of brevity, we're just going to focus on two things: the link between emotion and memory, and the link between emotion and attention. So, first of all, how do we study memory for emotional events in a laboratory? Again, it's difficult to manipulate real life high emotional events in a laboratory setting. And a complicating factor to that is that we've already seen that memory itself is reconstructive in nature. But we could try to study memory for highly emotional events, at least by some sort of approximation. So, what could we do? Well, one thing we could do is to try to see what the link is between increased arousal and then memory for certain events. And what we found through those studies is that increasing arousal tends to promote memory for a certain event, although there's definitely a limit to that. How do we know about this? Well, we know about the role of the amygdala in this particular type of memory formation, and it's been shown that some activation of the amygdala is actually good for memory and it actually helps to strengthen memory. We also know that if we block arousal by giving people beta blockers, this actually blocks those beta blockers in the amygdala, which then actually blocks a consolidation within the hippocampus, which again was a structure that we saw involved in the formation of long term memories. So, interestingly enough, this already is alluding to the possibility that the amygdala connects to the hippocampus, and that when long term memories are stored, they actually depend both on activation in the amygdala as well as activation in the hippocampus. Now, let's get a little bit more specific about the link between arousal and memory. So, a blanket statement that increased arousal promotes memory for an event, you can imagine that that actually breaks down at some point, such that when you're in an extremely aroused state, this may actually hurt your memory rather than help it. And that is indeed the case. So, what can we do? We can look at studies where we manipulate the amount of arousal that is present and then see how that influences memory either immediately after some sort of study period or 24 hours later. So, what was done in these studies is that people were given a bunch of digits, and those digits were either paired with high arousing or low arousing words, such as, murder, rape, incest, stuff like that, as high arousing words, versus low arousing words being table, chair, and so forth. They paired these digits. People were then told to study the digits, try to remember those as well as they could, and then either immediately or 24 hours later, they were giving a memory test to try to recall those digits. And what you see is that if the digits were paired with low arousal words, for the immediate testing, that actually benefited memory because people did better for the digits that were paired with low arousing words rather than with high arousal words. But 24 hours later, the words that were high arousal actually led to better recall of digits 24 hours later than those with low arousal did. So even though activation of the amygdala kind of flooded um, recall in the short duration, in the longer duration, it actually helped to promote long term memory. So that's interesting here that it seems that this is due to the fact that consolidation by the hippocampus takes some time. And then if you look at the role of the amygdala, it's helping in really activating the hippocampus and then helping with that long term consolidation. So the more active the amygdala is, in that case, this actually helped with memory formations. Now, as I already alluded to, there is a point where this breaks down. So people have looked at just actual real life events and how well people can remember certain real life events depending on how much arousal was likely present at that particular point in time. So, if you think, for example, about firefighters who went into the World Trade Center and tried to get people out, of course, that was about the highest arousal situation that you could possibly think of. If you test them for particular aspects of their memory for when that actually happened, their memory is actually surprisingly poor. And part of the reason for that may be that they were not exactly walking around then that day to try to remember what was going on. They were just trying to deal with the situation on the ground, and that was about it. So you see, at that point, memory actually breaks down. There's clearly an inverted U shape here where the relationship between arousal and memory is not linear. It is that no arousal doesn't really help memory performance, super high arousal doesn't help memory performance, but there's this sweet spot in the middle where you want to have some reasonable level of arousal, and when that level is present, it's actually most beneficial to your memory. What is the role of moods? Well, we've already seen too that there is such a thing as state dependent memory or mood congruent memory. People do better when where they study and what kind of mood they were when they studied is similar to the mood in which they are being tested. So this works better for recall than it does for recognition, it turns out. It also turns out that this works better for positive effects than for negative mood effects. So, in other words, being in a happy state when you study and happy state when you're tested is more beneficial than when you're in a sad state when you're studying and in a sad state when you're tested. We've already talked about this in the context of state dependent memory effect. So, again, the more congruent either either our internal and our external state is to when we encounter the information, the more likely we are to be able to recall that information better. Is there evidence that things like 9/11 actually lead to this thing that's called a flashbulb memory? And there's a lot of claims that people have flashbulb memory where they have this photographic memory. They can remember every last detail of the scene as it unfolded. Some people claim they have photographic memory for faces. And of course, this has been studied a bunch because people feel very certain about these memories. However, what's been found is that, first of all, the accuracy of those memories, just like other memories, actually does reduce over time. People become less and less accurate, unless, of course, they keep watching the same movies or the same pictures in real life, purely based on their memory recollection. What they claim to be flashbulb memories actually reduces in accuracy over time, just like any other memory does. And again, the reason for this is probably because memory is reconstructive in nature. It's subject to interference. It's subject to conditions of recall, later information that's being presented, and so forth. Now, the last topic, the link between emotional processing and attention. So here too, people have done studies where they basically do a version of the Stroop test that's emotional in nature. So rather than having the interference from the color name being spelled out, meaning the word red printed in green, you can also play around with these words not spelling the color name, but rather either emotionally charged words versus neutral words. So if you have rape, cancer, murder as the words, but the people's test is to just name the color of the ink, they've actually done this, and this is called an emotional Stroop test. What's interesting here is that emotion definitely captures attention. So a word like murder printed in red or green is harder to say the ink color for than the word table. This is especially the case when the emotionally charged words are negative emotions. So anything that's threat related, like murder, is actually a highly attention capturing stimulus because it's so emotionally charged. And you see this because people are then slower at doing the Stroop test accurately, so they either slow down or they make more mistakes. And this is especially the case if any of the words is actually relevant to that particular person. So, if you have a cancer yourself, or someone who was murdered, these words are even more emotionally charged, and as a result of that, the impact on your ability to name the color of the ink is even more severe. Finally, emotion can also facilitate attentional processing. So, for example, there's this test that's called the faces in the crowd search. And you basically ask people, it's almost like Where's Waldo, try to find a particular case or a particular face within a crowd. And what they've played around with in those studies is they manipulated the emotional expression on the face. So you can have faces you're looking for that have a neutral emotional expression, or you can have faces that have either a sad expression, an angry expression, and so forth. And what is consistently found is that faces that display an emotional expression are actually found more quickly than neutral faces. So, what that indicates is that the emotional system is definitely engaged differentially with the attentional system depending on whether a stimulus is emotionally charged or not.